momentum is a conserved quantity. Okay, so momentum is a conserved quantity, meaning it is saved. Saved through what? Well, let me show you. All right. So here we have a cart on wheels. We'll call it cart A. Okay, and cart A is rolling to the right. Cart A has a mass of 10 kilograms and a velocity of 10 meters per second. Does it have momentum? Yeah, right. Its momentum is equal to the product of its mass and its velocity. So the initial momentum of A is 100 kilogram meters per second. And so it rolls along there until what happens to it? When does that momentum change? When a force, right, is applied to it through a time. So when it receives an impulse, its momentum changes. So there is no friction, there is no air resistance. So that cart's just going to roll along forever with that much momentum. Its momentum is conserved. But now, as it's moving further down its path, there's cart B in the path of cart A. Cart B has a mass of 10 kilograms as well, and it is at rest. So what is the momentum of B? Zero. Right, so the momentum of B initially is equal to 0. Now, so that means A is going to collide with B. Now, the thing I didn't mention here is that A has a little device on it here, and B has a similar device on it, so that when they collide, they get stuck together. Right? So A is going to come here, and it's going to hit and connect by crashing into or colliding with cart B. Now, what was, let's define a system here. So we'll define our system as cart A and cart B. How much momentum was present in our system? So the initial momentum total inside the system, which is within the blue dotted line. How much momentum is in there? Total. 100, right? 100 plus 0. So there's 100 kilogram meters per second of momentum in there. Total. Okay, so A hits B. So that means A applies a force to B. Does B apply a force to A?
Yes.
Sure does. Is it bigger or smaller than the A on B?
It's the same.
It's the same, right? Newton's third law. It's the same. Now, is A in contact with B longer than B is in contact with A? No. So the force times the time then is the same for both of them. So what does that mean? The same impulse, the same change in momentum, right? So basically A is giving momentum to B, right? By pushing it that way. B had no momentum, A gave it an impulse, that means B's momentum changed. So now it's moving. B hit A, that means it changed A's momentum. Since it pushed A that way, it took away A's momentum. Okay, so basically you can think of it as some of A's momentum has now been given to B. But they're stuck together. So they're going to keep moving, but what speed do they move off at?
5 meters per second.
5 meters per second. So what is the final momentum if momentum is conserved? So if momentum is truly a conserved quantity, the final momentum in the system still needs to be 100, right? Because we save it. We don't lose it. We save it. It's conserved. It stays the same. So that means that instead of now 10 kilograms moving at 10 and 10 kilograms moving at rest, how many kilograms are in motion? 20, right? So P equals mv, there's still 100 kilograms in the system, that's the P. But now it's not 10 kilograms in motion, it's 20. These are stuck together. So 20 kilograms is in motion.
Yeah. Did you read my cheesy Valentine's Day card?
No.
Oh, good.
And that leaves us solving for V. V is 5 meters per second. Does that make sense? Right, because they need to keep that same momentum. So if there's more mass moving, the velocity has to go down. So A slowed down to 5, B increased the speed to 5, and they move off together. We didn't know anything about force, time, distance, acceleration, anything. And we were able to figure out the velocity. Okay, so that's why this momentum idea is a lot easier than the stuff we've been doing, the concepts we've been using. Let's give you another scenario. Same thing happens, except after the collision, the final velocity of A is 0. So A rolls along, the connection mechanism is no longer there. So A smacks into B and A stops. How fast is B moving? Somebody else. Rachel.
Meters per second.
How many?
10.
10, right? That means the final velocity of B needs to be 10. Because A's momentum goes to 0, right? M times V for A is 0. So then M times V for B needs to be 100, because there's going to be 100 in the system. Let's change it. Let's say the mass of A is 20. So what is the initial momentum of A? 200. B is still at rest, so the initial momentum in the system is 200. Now when they collide, the final velocity of A, let's make it 5. So they collide, they don't stick together, and A continues moving at 5. It slows down, but it does move still, it moves at 5. How fast is B going to be moving? Well, we know we need 200 inside, right? 200 total. How much momentum, the final momentum of A, is what? 20 times 5, which is 100. And that leaves us with another 100 we need. So that means the 10 kilograms that make up cart B need to be moving at 10, right? Final momentum needs to be 100, so that means this is moving at 10 meters per second. Does everybody follow this? Pretty simple. One last thing. Let's take this back to here. 10 and 100. 10. Now let's give cart B an initial velocity of negative 10, right? Now it's moving to the left, so it's negative. So what's the initial momentum of B? Negative 100. So then the total momentum in the system is 0, and it needs to be 0 after. So they both roll together, they collide. What happens after they collide? Okay, either thing could happen, right? And that's going to depend on the kind of collision we have. But for now, we'll say that they roll together and they hit and they stop. Because there was no momentum before, so then there has to be no momentum after. Make sense? Okay. Now, of course, there's an equation to go along with all this, right? So that's what we need. I know you're dying to get it. Okay. So let's get an equation here. All right. So we said the impulses are equal. So as A is rolling along, B applies a force to it. So the force of B on A times the time is equal to the force of A on B times the time. Except the B on A is negative because it's to the left. This is our equation from section 1. The impulse is the change in momentum. So this is happening to A. So the mass of A times its final velocity, or the final momentum of A, minus initial momentum of A, and that's negative because of the negative here, equals, this is happening to B, the final momentum of B minus the initial momentum of B. Let's put this negative through, so this becomes negative and this becomes positive. And then let's move all the initial values to one side. This was initial here. And all the final values to the other side. So what we have is MA VIA, or A's initial momentum plus B's initial momentum, equals A's final momentum plus B's final momentum. I can switch things around a little bit. And so this thing here is called the law of conservation of momentum. And so in the example we had here, the mass of A, or the initial momentum of A, was 100. The initial momentum of B was negative 100. So that equals 0. And then we said they're going to stick together. They're going to stop when they hit each other. So that means the initial final momentum of A is 0 and B is 0. So 0 equals 0. So this equation summarizes, or is the math for what we were talking about there. Let's part A, B. So this is the initial momentums. Final momentums. Okay. Now, A has a mass of 10,000, and it's moving at 24. So that's its momentum. B has a mass of 10,000. It's not moving, so it has no momentum. So the total momentum before the collision, 240,000. Now, after they collide, they stick together, right? So basically what we have is 10,000 plus 10,000, because we have 20,000 total kilograms moving now. And since it's one object, essentially, it has one velocity, right? So we can just do that. So then they move off at 12 meters per second. So you got, we'll make the guy A. Let me just use what I have up here. So the guy is 88 kilograms. He's at rest. The woman is 54. She's at rest. And then the 88 kilograms goes to the left, and the 54 kilograms goes to the right at 2.5 meters per second. So now you're left to solve for VFA, it needs to equal, the sum over there needs to equal 0. So this has to be negative, and then it's 1.5 meters per second.